more minute.
Yeah, I'll just kind of get started a little bit here. So we're going to be learning about
Would you like me to
the
introduce
command
you?
line. I guess, yeah, sure.
So, okay. We are all excited, and I see that Mr. Murray is excited as well. Brandon Murray is a teacher at McIntosh High School. He teaches computer science, mathematics, math is life, digital animation by way of Las Vegas. Okay, in his spare time, he hacks around with open source tools while scheming how to accomplish the same feats for open education resources. And he has a
Let's do this.
great passion for teaching others how to provide more inclusive, innovative, and industry standard computer science curriculum. So that is awesome. I would ask you also to take a few seconds to fill out the attendance form for the session. Okay. We'll have a question and answering, and they're saying you're echoing. Question and answer
All right.
period near the end. If you would like to come up, we'll go ahead and enable your video at that time. And the sessions are being recorded and will be available on our YouTube channel. If you would like to enlarge the presentation window, go ahead and double click on the window. Suggested that you use Google Chrome for the during the session, and please take screenshots, pictures, or whatever, and then tag us. Hashtag Constellation Summit, and I'll put that in the chat. And I'm going to go ahead and hand it over to Mr. Murray. Let's go.
Let's go. Let's do this. All right. Everybody can hear me. The echo's good. All right. So you'll want to double click on my screen. I'm going to share my full screen because I'm going to be bumping back and forth between some windows. Just so we know, this command line hacking panel, we are going to be talking about the Linux command line. And so part of this, you guys are going to be jumping on with me. So I'm over here. I got I'm going to build a cloud virtual server instance using the Ubuntu Linux distribution. And I'm going to just get that going. All right. So in the chat, you should see something about the Moodle.Murray math. Okay. So Moodle, this is a learning management system, just like a Blackboard or a Schoology. It's just one I'm hosting myself. So if you go to that link, you should see a course, command line hacking. You click that, and we're in the course. So I want you guys to let me know if you're able to get into this course so you can follow along. When it comes to command line stuff, especially when you're starting out, it can be really helpful to be able to copy and paste. Okay. So I built this out so that would be a little bit easier. But as you can see, we're going to kind of go through some different phases here. We'll talk a little bit about the history of this. Why is this still important? Okay. Just the basics of interacting in a command line environment. And then we'll talk a little bit about programming, and we'll see how much we get to. And then at the end, if you want to see how to get this stuff installed, the good news is, and one of the reasons I wanted to do this panel is because nowadays these tools are available on every operating system. Okay, Mac OS, they're built in. Windows, you can install Linux on Windows now. Chromebooks, you can install these tools on that. Okay, so and it's literally within the past 2 weeks that it's really come to a head, at least on the Windows side, where nowadays you can install a full Linux kernel inside of Windows and go to town. Okay, so just to kind of get skip to the end a little bit, why are we talking about this really ancient looking technology? Okay, why is this still important? Okay, and so I just wanted to share just a quick video with you guys real quick so you can kind of get a feel for this, that this is somewhat important, and it's important enough, say, for Microsoft. So tell me, can you guys hear? Tell me if you can hear anything from this. Okay. All right. Let's
No, sir.
Okay. Well, it's got some nice. All right. So that's what I was worried about. Okay. Well, then we'll skip that. You guys can watch this on your own if you come down here. Basically, what is going on here? I'll just play it. I'll just play it so you can kind of see it. What's going on here is this is Microsoft making what almost looks like an Apple commercial to advertise their Linux capabilities. And the music's real hoppy. So you might kind of recognize some of this on a Windows system, the command.exe program. This is a new terminal emulator for Windows where it combines the old command.exe, the newer PowerShell, and Windows's newer efforts to get Linux inside of its operating system. And so that's what you kind of see right at the beginning, right here. This is the Ubuntu symbol, okay? And this is literally within the last year Windows is doing this. Why is Windows like spending all this money to make this commercial and to build this new software for something that's really ancient, okay? So let's go like actually start learning about this then. So from this Moodle page, the history of Unix, okay? So the command line, kind of what you see here, really harkens back to early computing when you didn't have screens, okay? So you can kind of read through this. Because we're on a Linux system, Linux is just a clone of the Unix operating system, okay? Our command line is Unix style, and a lot of the software we're going to use was built on these for Unix, okay? And so, what is the command line? It has to do with the fact that back in the day you didn't have a screen, okay? All you had was what you call a teletype or a teleprinter, okay? And so, a teleprinter, what it would do is you would press a key and you would see that key like a typewriter. You'd see that character go onto a piece of paper on your paper roll in front of you. But it would also convert that key press to an electrical signal and send that down the line. And this is actually where your ASCII codes come from. Okay, so they were using these teletypes or teleprinters to do long-range electrical communication. So when early computers were coming around, you had to figure out a way to talk to them. So they just kind of retrofitted these teleprinters to be able to talk to a computer. So you were literally typing out on a typewriter-like machine some different sorts of commands or whatever. You hit enter, and the characters you pressed were converted into electrical signals and sent to the computer. And if the computer wanted to talk back to you, it would send a message back, and that message would get printed on an actual machine. So here is a 1930s teleprinter that somebody has hooked up to a Linux box. And so you can actually see right here, this is the machine talking back to them. And it presents him with a login. So he goes and he says, okay, well, let's see, will it work? That is the computer asking him for his password. What happens? Enter. Okay, he's in. We're in. They say we're in, and then it's going to do some really nasty looking stuff here. What is the legal? Some legal stuff, and they do like a fast forward, like. Oh no! Illegal disclaimer of doom. All right, so this is what the command line was, okay, and this is actually even a super extreme version of it because they built regular machines to interface with a computer. But here he goes. He's ready to go. So he's at his command prompt, and he can start typing out commands. So he'll type a command, hit enter. That command will get sent to the computer. The computer will run that program. and then it will send back the output, okay? Yeah, Margaret, we've come a long way, but the problem is that we really haven't, okay? So he just did a little command right there. This is important for making sure it doesn't print out like color codes, but he's going to do the ls command, and he's going to hit enter, and there it goes, okay? So he typed ls enter, and this printer is printing out what is in his folder. All right, so that's pretty cool. All right, so that's the technology behind your command line interface. But the specific command line interface is a Unix style. Okay, so for those who don't know what Unix is a what you call a time sharing operating system, so that you could attach multiple. Let's see. Are we still here? Am I still there? Okay. All right. I got you. All right. Yeah. I got you. So you could have multiple of these terminals attached to the same computer. You would log in with your username, put in your password, and you would do your work. And so you can see right here, this is the creator of Unix sitting at the terminal. His name's Ken Thompson. Unix was created through AT&T at Bell Labs. Okay. And Ken Thompson just wanted to make some games. He was, you know, a hacker sort. He wasn't super interested in the business side of things. He wasn't even super interested in the academic side of things. He just wanted to be on a computer. And so he found an unused mini computer sitting in the corner of this research facility, and he built his own operating system. And some of his coworkers started coming by and saying, "Hey, that's kind of neat. Can I become a user?" And so you can see right here next to him is a man named Dennis Ritchie, who created the C programming language. And so by 1973, Unix had been rewritten in C, which was a big deal, okay? Because all operating systems were written in assembly. You had to hand code it because it was specific to the machine. And so C was just a simple enough programming language that you could then make your system software, make your operating system. And from that, Unix was ported to other computer architectures, and started kind of trickling out from Bell Labs. Okay, and so kind of what made Unix unique was it was built by a programmer for programmers. Okay, and so there's different things that kind of go into, well, how did you use a Unix system? What kind of programs did you make on it? And that sort of stuff is what's called the Unix philosophy. Okay, and it has to do. There's a few different little pieces, but basically your programs are small. They're meant to just do one job and do it well. And then there's this special feature where the output of one program ends up being able to be used as the input to another. And so these two things right here ended up being like really, really special. Okay, and quite frankly, it's probably these design choices that keep us using this. Okay. All right. Please email my slides. Yeah, this is a website. I will try to email these. I wanted to make it so that you guys could download this course to be able to put on your own learning management system. Okay, so questions so far? All right, so why are we still talking about Unix? Well, it has to do with open source. Okay, so this is the hidden curriculum of this panel. Okay, is that open source is really cool, it's really important, and we should kind of learn about this sort of stuff. Right. Oh, nice, Laura. Well, what are you doing here? You don't even need to be here. So what happened was in the 80s, AT&T got broken up. AT&T got broken up, so they kept the Bell Labs thing, and because they lost, because AT&T lost the Bell telephone system, they started looking at Unix as something that they should be marketing and selling, and so that that changed the way that AT&T treated the Unix source code. Okay, so it had previously been they would send you the source code in C, and then they would you could compile it for your machine, and you could tweak it and change it. And so it actually led to some different lawsuits because there was a very famous version of Unix called the Berkeley system distribution, where they did a lot of hacking on the Unix source code from AT&T. And so there was some different sorts of lawsuits that kind of went around this with different families of this. And well, you got to get rid of all of our source code if you want to keep using your system. So that led to the birth of open source, or, and open source is founded on the idea that, copyright laws have these big restrictions, and you need to ask permission to do anything. So a gentleman named Richard Stallman, it's kind of a controversial person, okay, decided that he would come up with some specific, a different way to do copyright, a way that you can own the copyright without trying to put your software into the public domain, but to license it out in such a way that you give copyright rights, the things that are normally your rights, you give those rights to other people, okay? Or in the case of Richard Stallman's GNU General Public License, you give rights to the software itself, okay? And so nowadays, your different free and open source licenses, you're going to see that all over the place. If you're not already seeing it, you're using it, okay? It's everywhere. So Richard Stallman's big thing was the GNU project, okay? And the GNU project, what he did there, and him and a bunch of other hackers, they remade all of the Unix programs that they enjoyed. They just rewrote them from scratch, and they licensed them in this free model. Okay, so through the mid to late 80s, people are sitting there rewriting Unix in such a way that this software is now free. Anyone can use it. Anyone can modify it. The GPL, though, does have a special feature where if you want to modify their source code and then redistribute it, you have to give the changes back to the copyright holder. So it's sort of this, it's this way for, hey, you can improve my software, but you got to give me the improvements, okay? And that's actually been really powerful stuff, okay? So the one problem was they didn't have a whole operating system, okay? They had all the system software, but they didn't have a kernel. And so in the early 90s, there was a guy named Linus Torvalds. He was taking his own operating system class, and he had been using some of the GNU the software, and he just built his own little kernel. And so suddenly, when you combined his little kernel project with all this GNU software, you had your own free operating system, okay? And so nowadays, this stuff, like, it runs the world, okay? You're going to see it in web servers. You're going to see it on your Android phone. You're going to see it in supercomputers. You're going to see it in Internet of Things, okay? This stuff is everywhere. And for that reason, it is useful to understand the basics of how to interact in these environments, okay? All right, so just so we get a little terminology here, when you combine the GNU packages, which we will explore a lot of, with the Linux kernel, and you put them together, you get a GNU Linux distribution, okay? And the distributions might have extra software in them, but you have different groups and companies that take all this stuff together, they package it together so that you can have an operating system. So I'm running, let's go look. I'm running Red Hat Linux on this computer right here, okay? So again, Red Hat is a company. They package together all the software. They give you a big image. You install it on your computer. You got a free software, okay? You got free operating system. All right, so today, though, we are going to be exploring Ubuntu. And Ubuntu is kind of cool. Ubuntu is a really interesting word. It comes from an African philosophy that roughly says I am who I am because of who we all are. Okay. And that's a really cool, kind of powerful message. And that's really kind of what open source is. You know, I can
I had to.
run
Oh, I'm sorry. I
Red
had to
Hat.
tap that proverb every morning in elementary school. That same proverb: "I am because you are, because you
Really?
are, therefore I am." Yes, sir.
So, the guy who runs Ubuntu, the Canonical company, he's from South Africa. Um, so, that's cool stuff. Hey, open source. This is what it is because of what everyone is doing. Okay. Open source is built a lot on volunteers. Okay. All right. So I'm going to come back. I'm going to click here back to the course. This was our history. Now let's get started on actually doing some work. Okay. So if you want to follow along, let's see how many people we got. 43. It's going to be a couple. We might not be able to get everyone on here. Okay. But right here at Shell Basics, there's a link for GNU Linux command line practice. Okay. So this is where you can use this shell in the browser. The problem is demo server is currently running 12 users out of 32. Okay. So I'm going to go ahead and boot up my virtual machine. Let's see, failure, access denied. Uh-oh. Okay. Well, let's see. Let's try it. Let's try it again. Give me my machine. We can also connect to something I already have. Okay. All right. So that's gonna go. Okay. Here's my public IP. Boop, boop, boop. Okay. So I'm gonna show you guys this thing. This thing's gotta boot up. But okay, if some of you cannot connect to this website, let's check it out. Some of you might already be on there. Yeah, if some of you end up not being able to connect, if some of you are good enough at this stuff, you kind of get it, you can actually, you can connect to my virtual machine, okay, using PowerShell. So I'm going to, once this comes up, I'm going to create a user and have people be able to log in, and we'll get it done. All right, so let me just start kind of showing you the shell. I'm running a window called a terminal emulator. It's emulating one of those old teletype machines, okay? But inside the terminal is a different program that's running. The command line interface. Would this work on a Raspberry Pi? Yes, okay? You learned this because it lets you use your Raspberry Pi. Like, seriously. If you have Raspberry Pis, shoot, where's my Pi? Let's go see if I have it somewhere. No, I'd have to get out. I have to figure out the IP address. But what you do, and what I'm going to have some of you guys do, is you can use the secure shell program. Excuse me. Let me go back. The program that is running in this window, the thing that's blinking the cursor, the thing that's outputting this, what's called the command prompt, okay, is called a shell. And so in our course, it says shell basics. The shell accepts my commands and does them, okay? So I'm going to have some people, let's see, do I need to power it on? You can remotely connect to other machines, okay, using a program called the Secure Shell, and I'm gonna have us do that at some point. We might have to do that right now. And on my machine, but I got a ton of That's the worst part. That's why if your stuff is blocked, that's why I tried to come up with this. You should have PowerShell, okay, on Windows. Windows, type PowerShell in search. PowerShell has the SSH command, but SSH allows you to securely connect to another computer, okay? And when you securely connect to another computer this way, you're going to be presented with the shell on that computer, okay? So I am I'm in a different place right now on this guy, but it will look and act the same. Okay, I can get out. I'm back on my computer. I wanted this. Okay, are we on? Enabled, on, power off. Looks like we're on. Let's try it. I'm going to create a user. All right, so some of you I'm going to have try to connect this way. All right. All right. Add user. We're going to call this. What are we going to call this? They blocked access to PowerShell. All right. So can you use, if you can get that link to the Linux containers, you can just run this in the browser. User add. Okay. I'm going to create a user for those who can connect in PowerShell. What are we going to call it? What are we going to call it? Hacker. Okay. Add user hacker. We're going to call it Summit. And then I'm going to say user mod ag sudo hacker. Hold on, I got to do some nasty stuff real quick. Just make sure this is going to be allowed. Summit password. Sudo system control restart SSHD. Okay. SSH. Summit. Bang! All right. There we go. Okay, y'all. Sorry about that. Okay. If you want to be a crazy cool hacker person, if you can't, basically, if this isn't working, if this site isn't working because, well, I'm in it and I'm taking up a spot, sorry. All right, yeah. So someone else can jump in there. If this isn't working, you can run PowerShell on Windows. If you're in Mac, you can run a terminal. Shoot, you don't have to connect to mine because you have terminal and you're good to go. All right. Hey, dude, I'm doing something. Okay. All right, let me get this. 169.62.216.229. Hey, Mike, can you take off?
Okay. There's a question. Does it matter from Kevin here? Does it matter if it is Bash or ZSH?
Nope. If you are on Mac, it should default to ZSH, which is superior to Bash. I don't know it very well, but I do know that it's better. All right. So again, let me here. Let's if you want to follow along and you can get into PowerShell on Windows, you can type that into PowerShell. The password is Summit, and you can kind of do some of this stuff with us. Okay. All right. So Babu, if people are having trouble, let's try to troubleshoot. Okay. Yeah, how this would work in the classroom. I got a cool way to share this in the classroom. And also later on, if you want, you can see that you can all this on Windows 10 really easily, well, relatively easily. And then you would have it. Okay, so we'll go through that. Anyways, we gotta get started. Okay, command line basics. Let's go through this. All right, I am gonna connect to my virtual machine remotely, so because I want a clean deal. Yeah, Richard, if you install Windows Subsystem for Linux, it's not blocked. You just get a new command line window. It's Ubuntu, and you're ready to go. All right, so boom. All right, I'm here on an Ubuntu machine. and let's see how this stuff works, okay? You can't install anything. Ask your IT department. Tell them they're the worst. Okay, that's the worst. I'm sorry. Okay, so how does the shell work? You saw me doing some mumbo jumbo before. Let's actually learn the basics, okay? So the command line interface, what it does is it runs programs, okay? The shell, the bash shell or the ZSH, it presents you with a prompt. You type a command and hit enter, and it executes a program. Okay, network is unreachable. That's not good. Are there any virtual projects? Yeah, virtual servers. Yes, you can go on like Google, Amazon, IBM. Typically, will allow users to create a free virtual server. You could also run VirtualBox. I guess I didn't talk about that. You can virtualize a Linux environment on your system. I'm telling you guys that you can install this on Windows. The Microsoft Store, if you go search Linux, it'll be like, here, install Linux. All right, so let's go through this real quick. Depending on what system you're on, if you're in the website, if you're on the Linux Containers website, you're going to be what's called the root user, and so you're going to see a different symbol here. So I have prepared these slides as if you are the root user. Okay. If you're a regular user, you're going to see this $sign. Okay. So these are just the prompt characters. And afterwards, you type your commands. So let's look. The way that yes, if you see the pound, you're good. The way that the shell works, okay, is the very first thing you type has to be the name of a program. Okay. The very first thing I type is the name of a program, command not found. Okay. So this is what is hard for new users. Well, it's like a blank page. It's like you're a painter and you got the blank canvas in front of me. What do you put on there? If you don't know how to paint at all, if you don't know the names of any programs, you can't do anything. Okay. So how do I type the name of a program without knowing the names? So let's just go through some common ideas about how Unix style utilities work. Okay. So due to the limitations of the early hardware, you didn't want to have to type long names. So most of the basic program names are just abbreviations of something that you want to run. So for example, the program used to copy files or move files, they get abbreviated CP and MV. Copy is CP, move is MV. All right. So let's go look at a few different programs just to kind of get running on them so we can see how this works. Okay. All right. You guys ready for this? I type the word date. I hit enter. Gives me the date. Ta-da. June 16th, my birthday. Oh, that's so nice. I like that. That's so cool. All right. Here we have a program called PWD. What's PWD stand for? Print Working Directory. Okay. We got another program. Who am I? What do you think that program does? Tells me who I am. Okay. How about a program abbreviated CAL? What do we think CAL might do? Hit enter to find out. Calendar. Prints out a nice little calendar for us. June 16th. Oh, that's so cool. Yes, root. All right, if you are root, be careful, okay? Everything here is built for root. So if you're in the Linux container, you're good to go. If you're on this guy, you're good to go. If you are like me, you're going to have to do some special things. Okay, it says bash cal command not found. All right, well, okay, type this. Oh, wait, hold on. Type that first, then. Actually, I don't know if that'll work. Whatever. Don't play with root. Okay, so let's just go through. The first word you type is the name of a program. Okay? So that first word, you got to know what you're doing. Okay? You got to know what you're going to call. But oftentimes you're going to be adding different little options to your program invocation, okay? So how that works is we type our program name, we type a space, and then we give some options. And so here for the cal command, it looks like you guys don't have the cal command, so I'll just kind of show you. But oftentimes these options start with a little dash symbol. So I'll just kind of show you. If I say cal-y, what does that do? Changes the cal program output to print out the whole year. Okay, and it still highlights my thing. If I say cal/w, oop, wait, that didn't work. Okay, how did I mess this up? All right, whatever. W. Okay. All right. Well, now I'm screwing it up because of course I am. So again, we're gonna see this a bunch. You have your program name. You have program options that you pass to them. That's the basics. Okay. So some programs though actually require us to type a little extra. So for example, there's a command called touch. If I just type touch, what does it say? You're missing a file operand. Okay. Touch needs us to say something else. Okay. So what did that do? All touch does is it creates a new file, or if that file's already there, it updates like the last access time. You know, the operating system keeps track of when you access files, when you change them. The touch command will either create a blank file or it will update the access file on something. So let's look. If I look in my folder, the ls command, the ls command lists out what is in our folder. Because when we're in the shell environment, it's kind of like a file browser. Okay? There's folders and there's files. Okay? But we have to enter in commands to see what files are in our folders or to move to different folders. So the ls command lists out what is in our folder. Okay? So you can see if I want, I can do the touch command again. Hit ls, and now I have some extra stuff. Hey, people are in. Who's in there? We got some hackers. All right, nice. Now I know where you. Oh, I'm gonna hack you. I know where you're at. Okay, I should probably clear that out. Okay, so we gotta say a program name. We can give it options. We can do special things like list out where we're at. Okay, somebody's removing stuff. But like, how do you know what options to use? Okay, and so there are a few different utilities to help you figure out like kind of how to use different programs. So for example, the most basic one is what's called the man command. Okay, so the man command works by first you say the program name man space, and then you type in the name of any other program that's on the system. So I'm going to look at the man or manual for the ls program. Man, ls, enter. And here I am. Okay. Look at it says at the bottom, manual page ls, line 1, press H for help, Q to quit. So this is telling me ls lists directory contents. It gives me a quick synopsis of the usage of this. Anything in brackets is optional. So ls, first you give it options, then you might give it files. You might put a file name to check to make sure you have something, and we'll see another use of the ls in the file. Okay, and then here's a bunch of list of options. All. Ignore backups, list entries by columns, directory. Okay, so this is pretty exhaustive. But this is how it works. So we're going to use this one, the -L, use a long listing format. So I press Q to quit out of my man page. I say ls-L. Okay. This shows me what's in my folder, but it gives me a lot more information. Okay. Including when it was created or when it was last accessed. Leo, you can install this on Chromebooks, okay? This is the hidden curriculum of this presentation. You can do this everywhere, except if your computer is like totally locked down, you can't do anything, in which case maybe you go browser-based and get some sort of virtual machine. I don't know. Okay. So do we got the basics there? We can list out contents. We can run commands. We can run commands with options. We can even get help on a specific program using the man command. Okay? Display account. And the date of Easter. For some reason, Easter's a big deal for this program. Okay. Easter. Cal-E. Where's Easter? What? You're not even going to work? You jerk. Whatever. E. All right. Okay. So, yeah, Ms. Fuller, we will see. The cal command sounds like it does not work on the online version. Okay. So just so we see, there are different ways to get help on different programs. Most programs have a -- help option that will give you a real quick usage. Okay. This one is, yeah. So it'll go through all those command line options. Other than the man command, there's also what's called the info command. Less of these works. Thanks, Kevin. Info gives you more information about certain commands. Mostly the GNU project stuff. These are basically tutorials. Okay, like full stuff. And then there's this guy called Apropos. Apropos is how you can find a command that does something you want. Okay. So if I want a command that has something to do with directory contents, I say apropos, and I'm putting this in quotes because I want it to search both of these things. Directory content. Oh, you son of a biscuit eater. Okay. Yeah, apropos sometimes doesn't work. I have to update the man database. All right. Does that work in the online? Ah, man. Pain in my butt. Here. Okay. There. Bang. Okay. Apropos will search the man pages to see what a command does. Okay. All right. Let's get back in. Hacker. Son. All right. So let's talk about how we move around. One of the deals is that in this command line environment, you're like in the dark. Okay. So some basics. One of Unix's original contributions to computing was the design choice to treat everything as this unstructured stream of bytes. Okay, what it calls a file. Okay, our input that we type in is a file. Okay, the keyboard, when the operating system reads your keyboard, it's just getting a stream of bytes. It treats that as a file. Okay, so just some understanding of this. Because there's no difference in the way files are treated, file extensions don't matter, okay? So you don't have .exe at the end of stuff, right? You don't have .txt, you don't need that. Really, all file extensions are on Unix are hints, okay? This is a .txt, this is a text file, okay? Like our programs on Unix don't have a .exe extension because otherwise, to run the program in the shell, you'd have to type ls.exe. Okay? Yeah, most of the commands are not working. Does man work? Yeah, info probably doesn't work. All right, hey. Yeah, okay. People in the container. People in the container. Type the... Let's see, where is it? If you're in the container, you can type this. You can just straight connect to our machine from your container, I believe. Somebody correct me if I'm wrong, but this will at least get you in. If you're in the online container, you should be able to type that phrase, that command in, and it will just connect you. I wonder if I'm wrong. All right, let's try it. since the container is not working very well. Hacker at 169.62.216.229. Never. Okay, right. Shit. Okay, well, we should be able to get some commands that will work. I know that some of this later stuff does. Okay. All right, we got 30 minutes. We gotta grind. So here's the basics. Just like a file browser, okay, you're in a folder. Okay, print working directory. I'm in this folder. I can list out what's in there. I can change directories with the CD command. Yes, continue connecting, Richard. Okay. The CD command will let you change folders. So this is the first big folder to know about. It's a folder whose name is the folder separator symbol. Okay, so if I type cd space / pwd, I'm in the what's called the root directory. This is the base directory for the entire system. Okay, so type in cd /. That will work. Yeah, don't worry. Once your container thing goes away, you'll just refresh and you'll start a new one. It just closes it out on you. Okay. So just let's do cd / and then look around. Okay. And you should see on my system they're in blue. Those are directories. Okay. But this is your root directory. Everything is somewhere contained in there. And this is a little symbol, or this little graphic kind of gives you some brief descriptions of what of where to find stuff. Okay. All right. So everything in Linux, instead of folders, we call them directories. Okay. Every directory is contained in the file system's root directory. That's /. Okay. You might see a folder called the root folder. Okay, can't even get in there. The root folder is the home folder for the root user. If you're on the online one, then you are root, and that's your home folder. But the root directory is this /. Okay, so this is where we're at. cd / ls. Okay, well, we can move around with this cd, the change directory command. Okay. So if you want, you can display all the contents and you'll see some different stuff. There are some kind of special kind of like folder names that you'll see. As you see in the channel. Okay. Okay. So these are all my folders. All right. So here's what I want you to type. I want you to type this guy, cd user bin. Okay. So when you type and you type /user, if you start a file name with this symbol, you start at the root directory. You start at the bottom. Okay. So cd this user /bin, and now I'm in that folder. Okay. Yeah. So user bin is where a lot of our programs are. You can ls in here, but you're going to get a bunch of stuff. Okay. So just so we know kind of how to move around a little bit better, if I want to go up to a parent directory, then I use this ... notation. I say cd ... Okay. And then we'll start coming down. Now I'm in the user directory. Okay. And if I hit ls, I'll see that bin directory I was in. Okay. And if I cd ... once more, I'm back to my root directory. Okay. So you can play around with this. cd home. What's in the home directory? Ah, my hacker. Okay. What's in the hacker directory? Oh yeah, that stuff. Let me come back down a couple. Out of my home directory, out of the home directory, back in the root directory. Okay? These commands should work, because if they don't work, your system is totally busted. Okay. So just basics on how to get around. Okay. The CD command. We'll talk a little bit about absolute versus relative addressing. We'll talk about that in in a couple more slides. All right, so we can see around the folders we're in. How do we see into files? Okay, so I'm going to bring us into a directory called the Etsy directory. All right, so I'm going to go cd Etsy. Okay, and Etsy's got a bunch of junk in it. All right, I'm gonna get that real nice for you guys. Okay, so the Etsy directory is where configuration files are held. In Linux and Unix style systems, since everything is a file, they just decide, hey, let's just configure the whole system with just plain text. Okay, so then we can read it and you can change it how you want. So oftentimes we use the cat command to real quickly see inside, to peek inside of a file. So let's run these three commands: cat legal, cat time zone, cat environment. Each of these words are files that are in this Etsy folder. Okay, cat legal. The programs included with the Ubuntu system are free software. Okay, cat, what was the second one? Time zone. The time zone file just has these letters in it. That's it. That's all that's in there. Okay. And then let's see this guy, because this one's really important. The file called environment. This is very important. I want everyone to see what's going on here, because this explains a huge aspect of this environment. Okay. The environment file in the Etsy folder has in it this line: path, all capitals, equals, and then a string. You should recognize what these are: /user, /local, /sbin, colon, /user, /local bin, colon, /user, /sbin, user bin, sbin, bin, user games, user local games. Okay, the path variable. Here's what this is. In the shell, there are variables. The shell is actually a programming language, and it has variables. And some of these variables are really important, and they're called environment variables. And you really can't do much if these environment variables aren't set correctly. What the path environment variable does is it gives you a list of folders that the shell will look for the program names you're trying to run. Okay? When I type cat, okay, the shell is going to see this word cat, and it's going to go look in these folders for that program. Okay? Does that make sense? This is real information. Okay? So we can use cat to look inside of files. Okay? And we sometimes, if we want to see inside of those environmental variables, then we use another command called echo. And echo is kind of weird. Echo just literally says whatever you say. Echo, hello. Okay? That's not very useful. Okay? However, it can do things like this. Okay? Your environmental variables, you have to use a special notation. You have to use this $sign, right? When you set a variable, it's just you say the name. Usually they're all uppercase. But if you want to access it or use it, you have to put a $sign in front. The shell is going to interpret the $sign as, hey, you're talking about a variable next. Okay? So let's go look at a couple of these shell variables. The home variable tells me my home directory. The shell variable tells me what shell is running. This is the bash shell, or the born again shell. Okay? Okay? And if you want, you can run the env command, which will list out all the environment variables that are currently active in your shell. There's path. There's shell. Ooh, I'm term xterm 256 color. Okay? SSH client, print working directory, the home variable. Okay? All right, so Are the commands case sensitive? Yes, typically. Most stuff is case sensitive here. Okay. All right. So here we know how to get around and we know how to look around. So the important one here was this path variable. This is how the shell finds these commands that we're searching for. Okay. It wouldn't find, if I wanted it to find a command somewhere else, I would have to tell it where to find it. I can actually include the directories leading up to a command in order to execute it. But if I just type a command, the shell will search the path variable and find that command. Okay. All right. So we gotta zip through. So just some basics. Your user belongs to a group. You also have the super user. Okay. So we saw before, who am I? I'm me. What groups do I belong to? I belong to those two groups. And my user is going to have his own home directory. Okay. The thing about files is that they belong to different users. If you don't have privileges because you don't own it, you can't really do much with the file. Okay. So if I come back to my root directory and I do the long listing, I'm going to see that all of the stuff in here is owned by the root user. Okay. And over here is this weird string, D, RWX, R-X, R-X. Okay. This is actually telling you who owns stuff. Okay. Or what permissions you could have. The first three letters tell you what the user owner can do with it. Read, write, and execute. The next three tell you what the group user, that's the second set of words, can do with it. The third set tells you what everyone else can do. And so in the case of all these files, I'm not the root user. So all I can do is read and execute, which means in the case of a directory, I can go inside of it. Okay. I can use the directory, but I can't write to it. I cannot change the directory. I can't change anything inside of it. Okay. All right. So I do want to get past this stuff because I want to get to the programming. Because you guys are like, all right, great. Why? Okay. How about I just go into a folder? Yay. I'm in my folder. Okay. How about I create new? Okay. All right. So just so you know, you can copy files. You can move files. You can remove files. There are some special things for, say, I want to remove everything that starts with the word file. That star is called the wildcard operator or the glob operator. RM for remove, file star, it will remove everything that starts with file. And then it uses a wildcard and it says you can just take anything after that. Okay? Be careful with remove, especially in the, hold on, I'm going to do it. I'm in. Okay. You guys, you're toast. I'm in the root directory. Be careful with remove. Okay. Remove recursively and force it to happen. The entire file system. Okay. Remove rf/no. Preserve root. Do you know what this will do, guys? These are the options. Recursive, that means go into folders and delete everything in the folders. F means force. Don't ask me if I'm sure. I'm sure. Slash means everything in the root folder. And no preserve root means I'm crazy. Thank goodness for the restore command. Richard, I don't even know the restore command, but I do know that I'm destroying this container right now. I mean, it is toast. Okay, so yes, you can be okay. Device busy. LS can't find. There's no LS program. PWD. Oh, that's a yeah. PWD is a built-in to Bash. So I'm done. I can't do anything. Where is LS? Where is command not found? Okay. All right. So I have just completely toasted. I deleted everything. There's no, yeah, okay, so that's dead. All right, so some special shell features, just so you know. Okay, this will get us out of how the shell works. Okay, there's some nice things because it's hard to type stuff in, right? The tab key can autocomplete things for you. If you're typing a command or a file name, the name. So I can say cat OH. If I hit tab, it'll complete it for me. I can just type a T, okay, and hit tab, and it'll complete it for me. Okay, so this is really useful. Let's see. If you double tap tab, if you double tap tab and there's more than one thing that could match, it will show you all the things that can match. Okay, even if I type CAL and double tap tab, I'll still get all the things that can go. Okay. All right, so tab completion is really useful. There's also the up down. Up down will go through previous commands. Okay, so that's helpful. Yeah, let's go back here. So CD U, oh, tab, it went in. CD B tab, it completes it. Okay. So this is just basic nice things to make it easier to do stuff. There are some keyboard shortcuts, and if you're on a Mac, I think most of these work. Control A will bring you to the beginning of a line. Okay. Control A, now my cursor's at the beginning. Control E, now my cursor's at the end. Control U will delete everything before my cursor. Control K will delete everything after my cursor. So you can kind of use those together sometimes. I'm in the middle. Let's go to the beginning, kill everything. Okay. I'm in the end, go to the end, kill everything. Okay. All right, and then some more kind of special features. Strings. You can use strings in the shell. It's a programming language. Okay. So double quotes. Double quotes are interesting because it will replace your environmental variables. It will show you. It will actually do that for you. Single quotes will not do the variable substitution. Okay, so these are just things that you gotta kind of understand. And if you want to use special characters that have special meanings, okay, so like a single quote or something like that. If I try to say, if I want to use a quote in my string, I have to use the escape character. And you guys maybe you're familiar with this in different programming languages. Okay. Oh, I screwed that up. Okay. I'm worthless. All right, I guess that doesn't work. Okay, environment variables we talked about. Okay, the path variable is really important. That's where it finds the program names. You can create your own variables. Okay. Okay. So I created my variable, and boom, there it is. And then we have this idea of absolute versus relative addressing. If you start a directory name with a slash, it starts from the beginning. If you don't start with a slash, it starts from where you're at. Okay, so if I say cd bin, I'm in the bin folder. Okay, if I say cd user, I'm in the user folder. And if I now say bin without the slash in front, I'm using relative addressing. I'm starting from my current directory. Okay, and I'll get into this bin folder, as we can see. Okay. Okay. All right. That's how to interact in the system. Do we understand the basics of how this works? Give me something in the chat. I understand how this works. I can get around. I can type commands. I know how the shell interprets my commands, how they have options, because now we're going to do the actual cool stuff, like the really, really cool stuff, why you should pay attention to this, why you should even be in here, is called package managers. Okay, I've talked already about open source, being cool and important. Okay, this is where it's so cool and so important. Watch this. Okay, I can install whatever software I want with a single command. Okay, so I'm going to type this. If you are on the online container one, you do not have to type the sudo command. Sudo is a special program whose job is to give me super user privileges and do one thing. Because if I'm running around as the super user, as the root user, and I remove the wrong stuff, I'm in trouble. Okay, so this is just, hey, I can be myself for a little bit. I can get super user privileges when I need it, only for a single command. So what it is here, I'm just gonna switch to my super user. He doesn't have a password. Son of a biscuit here. Okay, I'm gonna switch to my super user. Okay, so the APT program is the Ubuntu package manager. Let's type this in. You can do this in your Linux container. Okay, apt space update. Here's what this is doing. This is going to different websites where it gets a list of software I can install. Okay. All right. Ms. Fuller, check this out. This is cool. Okay. I can install now using the apt program. I give that apt program the install subcommand. So before I told apt to update itself. I'm running the apt program again, but now I'm telling it to install, and then I just tell it to install something. Watch. I want you to install Vim. Apt space install space Vim. You ready to go? This is going to get cool. Okay? It goes reading package lists, building dependency tree. The following packages will be installed. Here's some suggested packages. Following packages will be upgraded. Do you want to do this? Heck yeah. Okay? It's downloading software from the internet and installing them on my computer. Okay? In a single command. And should be done by now, but whatever. And it's like literally that easy. Okay? And I'll probably show you this here I'll probably show you this now. I have something at the end. I don't know why it's hanging. Did somebody come in and try to overwrite me? All right, there we go. So I just got the Vim. Program. I don't think we'll talk about text editors right now. The Vim program is a text editor. If I wanted to, Vim is a text editor. It's how you can actually add text to files. Okay? It's kind of hard to use, though. All right. You want to see something? Okay, fine. Install Emacs. Okay? Oh, no, I messed it up. Okay, fine. There. You want Emacs? There's Emacs. Richard? Although everyone knows Emacs is the inferior text editor. It is definitely a superior operating system, though. I'll give you that. Okay, so I want Emacs. Hey, give me Emacs. Oh, God, Emacs is so huge. This is Richard. You have poor tastes. Okay. All right. You install software like this on a command line. It's really cool. Can you write your own command using list in Vim? No, but I can use Vim script. No, I can't. I don't know how to do that. All right, I want to show you this one because this is really important. Seriously, this is important. Hey, Linux got useful because it runs the internet. It still runs the internet. If you are running a website, you're probably logging in like this to do you can do some fancy business. So check this out. I can install what's called the Apache web server. Okay? And I can do that in a single command. And once I hit this, do I want the web server? Yes, give me the web server. Thank you. Okay? Once I do this, I have a web server on this machine. Y'all want to check it out? Go into your web browser. Type in the IP address. There's our website. That is running on the virtual machine that we're on right here. And do you know how I did that? That was it. I got a web server. Hey, it's Babu. Let's go edit that website. Okay, Apache 2 default. Let's see, what is this? Let's go. Let's find that it works. There it is. Okay. So I just edited my HTML, and there it is. So it really is that easy to install software. That is quite honestly why this is important. If you want to get anything from this, just know, oh, I'm in a command line. What do I do? Well, I know how to do commands. I know there's variables that handle certain things for me. And I know that I can install software in a single command. Okay? That is why this stuff is important. If you need something, you can come get it. Okay? Okay. And because we're running this on Linux, we have the whole open source ecosystem available to us, like right here. Okay. So I'm gonna have to cut this off. We didn't get to most of the programming stuff, but you can kind of check this out. Like web development, this is like, hey, you install a web server, there it is. Python. Python has its own package manager. I mean, we have Python. Where is Python? There's Python. Now I'm running Python. Okay. Python is built for this environment. If you want, you can get Python's package manager. Hey, I want Python's package manager. Let me apt install it. Yeah, give me all of that. All right, so Rich, why I'm doing this though is honestly because one, this stuff it really is everywhere in the software development world. And I'm doing another workshop later on Git and GitHub. And that's kind of the end point to all of this is kind of knowing how Git works and being able to use it. But the fact is Microsoft has made their own, they have put Linux in Windows, right? And the reason they did that is because people use this stuff. I mean, the package manager is so sweet, right? There, I have my Python stuff. Pip3, install, movie, py, okay? I can get any Python package I want. I just do a single command. And now I have something cool from Python. From movie.py.editor, import, give me everything. Oh, no, I don't have something. No ffmpeg exe could be found. Okay, well, let me go get ffmpeg. Yeah, I want all of that. Okay? So is this something that you are going to always do with your students? No, probably not. Although I have taught a computer programming class where I made them do everything in the command line. And it was hard and it was probably the wrong idea. But, you know, when we went to go learn HTML and we would install our own web server, you know, we would go on Khan Academy and do their HTML stuff. And after a while, once they kind of got it, they said, hey, we're tired of this. Can we go back to the real thing? What? Like, you want to go back to the terminal to do HTML? They're like, yeah, this con stuff, this is just a toy. Can we go do the real thing? And that was like, that like blew my mind that they would actually prefer this. Okay. I don't think that is probably a standard thing, but you know, this was at a Title I school. I mean, this was as diverse of a class as you could get. Kids that didn't know anything about computing, really. They knew what games were. And eventually they got comfortable with this and were saying, hey, let's do this. You know, I want to do this. I want to learn, you know, how to do this the way that, you know, a web developer might. But you know, teaching the basics, I mean, hopefully you guys got some of the basics here, how to get around. You can teach the basics pretty quick. And if you want to do if you want to have your students host their own web servers, I've done this in all my classes. We download this just enough to be able to install a web server, and then we use graphical text editors to edit our websites. But then the students will come in and we'll change up a couple files on their systems where they can visit each other's websites by saying, go to computer 1, go to computer 2, and they can visit each other's websites, right? Yeah. Batavia, I need to make this available. I will do a shout out maybe in the chat for how you can download this thing for your LMS, but I'm not comfortable enough with Moodle how to do this. But you know, this Moodle thing, I mean, I use Git. Let's go find my Moodle. Let's go FOSS at Ubuntu. Okay. So I'm running this this website that you're seeing on a virtual machine. I used the command line to download the Moodle code. I downloaded a web server to run it. This took, you know, I'm paying some money because I'm using a virtual machine. But you could do this on your home computer, and it doesn't even need to be a good home computer. It could be a Chromebook. It could be a dinky Chromebook. Okay. But I'll post up to show you guys. I'll share all of this so that you can put this into your LMS if you wanted to play around with it. Okay. But thank you. That's all my time.
Okay. Yes. Thank you. That was tremendous. Oh my gosh. So we do want to thank you all for attending and thank Mr. Murray. You know, this was a lot of information. Command line takes some of us back, way back. If you don't forget to visit his site. His site is still pinned at the top of the chat, so you can kind of go through this yourself. You can watch the recordings once they become available on our YouTube channel, which is also posted on the chat. Also, if you didn't get a chance to, make sure you fill out the sessions attendance form if you haven't left already. We do thank you once again for sharing this information with us, Mr. Murray. This was very exciting. I was getting comments about how I'm having too much fun back here watching this.
I'm doing another workshop today, later, 4 o'clock. Okay, we're going to talk about the Git software system, which if you don't use this stuff, and I don't suggest that most people use this in class, but if you end up in a shell environment, hopefully now you kind of know what is available and how to get around. But if you're going to use some open source stuff, Git is a really powerful program, and it's you know, you get started with it in the command line, but it also ties into your text editor, so you don't have to be stuck in the command line. So that's at 4 o'clock is my plug.
So come back at 4 o'clock, you know, and let's all, you know, some of us have already done so, but wish
Thanks,
Mr. Brandon Murray a happy birthday.
Thanks, y'all.
So it's break time. The next session should start at 11:30. We'll see you then.
All right, thanks, y'all.
All right, great job.
All right, let's see. Let's do some fun. I'm still on it. I'm not even. You can leave if you want, but I'm in it. Contact info.
Oh yeah. How can they get in contact? Like, is it on the website, the murraymath.com?
I don't think so. Here, if they don't, I thought the thing was going to close down, but I'm gonna go in and do some. I'm gonna do some coding here. All right, so open source coding. Okay, you can leave or you can stay. I don't care. Okay, I'm doing it because I love it. All right, open source coding. We got the ability to make software really easily. So I'm gonna come in here and I'm gonna download. Look, I can from the internet with one command and a URL. Give me that. I want it. You got it. Okay. I need to unpack this, what's called a tarball. I'm going to need a special thing to get rid of the .lz. I'm going to install this software, Summit. Okay. Install. So I need that real quick. Got that. Okay. lzip, decompress my ed. Okay. It's decompress tar xf. I need to undo the tarball. There. I got my folder. So here I got my open source software. Okay. Open source software is really easy to configure, or really easy to make, because they give you a couple different things to do it really fast. Okay. So you got this green dude is called the configure script. I can run software from my current directory by using this // meaning from here, from where I am, run the configure script. It made sure everything looked good, and it created what's called a make file. The make file has instructions on how to build the software. So it goes in and it builds it. All I have to do to build the software is say make. Ta-da! I've just built the software, which is pretty cool stuff. If you have the source code, you can go in and, well, I'm gonna use ed. I'm gonna use ed to edit ed. You can edit the source code however you want. So I'm in ed. Ed is a line editor. Imagine you're on a printer, so it doesn't even show me what I'm seeing right now. Okay, plus insert printf. All right, so we just edited the source code. I'll remake it. Expected declaration before. Oh, I guess I've screwed up. All right, let's get in. Let's get back in. Okay, there we go. So I can edit the source code if I want. I can change it up. I can rerun it. There, I edited the program to include that line, and there it was. Yeah, so not the best way to do a lot of coding. It's kind of a pain to sit here and code like this in something like Vim, but it is possible. Well, but you can go ahead and configure, install software through source code. So I'm getting the Git software right now. So I just download the Git source code. I unpacked it. I'm in the Git source tree. I run my configure script to make sure that I can run it. It's going to yell at me. Well, not yet. It says, okay, I made the make file. When I try to compile Git, it goes, you're missing something. This is called dependency hell. So I need to go get the thing I'm missing. So I'm going to install this software. I'm going to get it. I got it. I'm going to unpack it. What is it called? I'm going to unpack it. I'm going to go in there. I'm going to configure. I'm going to make it. Are you done? Are you done yet? Are you done yet? And then I'm going to install it. So I just installed the zlib package, and it was pretty easy. And I come back in here. I'm like, all right, make my Git. And it goes and it starts compiling everything. I'm compiling open source software. It's so cool. I didn't even know. I don't even have to know how to program. I just have to know how to say the word make, and it'll do it for me. But because I'm in dependency hell, okay, it's not gonna work. So it's gonna fail at a certain point because I'm missing extra stuff. So instead of compiling that stuff from source code, this is where your package manager can be so useful. So I'm like, all right, come on, Git. If I'm trying to compile some sort of package and it's not working because I'm missing something, I can just real quickly use my package manager to download the missing components, the missing dependencies, so that I can get what I'm missing. And you're almost there. You're almost there. Let's give it a second. So later is the Git, getting into Git. So I am compiling Git from source code right now. It would be easier to just, use my package manager to install it, but I'm just showing that you can. And then it should fail pretty soon. Once it does the documentation, it fails. It is actually possible to install all of your Linux software from scratch. You can build your own operating system from the source code using this project Linux from scratch. It will tell you what to type in. You literally copy and paste. Oh man, this took longer than I thought. I thought this was shorter.
So how long have you been doing
There's the error.
Command line programming?
So when I was in school, we had to SSH into our Sun machines. We had to use the GCC compiler. It was a C++ class, but they didn't teach us how any of this worked. They just said, run this command, okay? Nice, you built Gentoo. That's really cool. Right, you don't need to know C. You don't need to know the stuff to know how make works, okay? Uh-oh, no, you're gonna fail. So when I graduated college, I didn't end up, let's see, building dependency tree. I didn't end up finishing computer science. Hollywood for a little bit. I guess I screwed this up. Okay. And I got like a really tiny computer that was really worthless. Oh, it worked. Okay, we got Git. There it is. We got Git. Get in it. And I got a tiny cheap $99 EEE PC and I put Linux on it and I started getting back into the command line. So I've been messing around with it for about the last 10 years. But in terms of like seriously, like, how does this stuff, I'm going to learn this so I can teach it. You know, I believe in it. This is the gateway to open source. And it's not that hard to use Git. Let's do, where's my, no, where did I have it? You don't need to know C to compile a C program. I mean, we just saw that. Here's the ed. Let's just remove the ed folder. Okay, ed is written in C. It's a bunch of C files. But in order to compile open source software, typically you run a script called configure. It creates a file called makefile, and you say make. The make program looks at the make file and builds it. And now I have my own system software. Yep. So yeah. So this is cool stuff. Except for Ed. Ed is not cool, except to me. Yes. What line am I on? Go to the next line. Imagine you were trying to type a text file on a printer that didn't have a screen, right? You could sit there and you could tell it to show you parts of the file. Where am I at? What's going on? Did I do something wrong? I did something wrong. Oh yeah, I know I did. Show me a couple parts of the file. Man, oh Jesus, I'm stinking at this. Let's go make a C file. Oh yeah. Okay, insert mode. Imagine you were at a terminal station and you didn't have a screen in front of you. You were just typing things out. And so this was kind of a pain. If you wanted to change your file, you would ask it where stuff was. So I can print out my file. I can go and I can like copy lines. Let's see if I remember how to do this. Let's see. Take 4, copy. Or is it T5? Let's see if that worked. Yeah. Okay. So you can copy stuff. You can delete lines. You say line 6 delete. It deletes the line for you. But you would just kind of peek. You just kind of like peek at certain lines. Let me go look at those, and then on your printer, it show you those lines. But this is not how you should be programming anymore. Although it does work. I have my C program. Let's compile it. Compiled the C program, and there's my hello world. All right, so Babu, thanks. I'm gonna get out of here so I can go watch other people.
Okay. Yeah, I think the next thing is on the main stage in about 1 minute. All right. Thank you all once again for
All right,
coming.
perfect.
Those that stayed.
Yeah,
All right,
are
great
super nerds
job.
and they
Right.
probably
Right.
not happy.
Yeah, I was nerding out.
All right, thanks, y'all. We'll see y'all around. Let's see.
Daddy, I got a present for you. I got a present for you, Daddy. Here we go. Daddy, here we go. Here's your present. And here we go. Daddy, here's your present.
Thank you. Oh, thank you so much, sweetie.